Hello everyone, welcome to my channel. In this video, we are learning about Perceptron. So let's get started. What is a perceptron? A perceptron is the fundamental building block of deep learning. It is invented by Frank Rosenblatt. Perceptron is the simplest form of an artificial neural network designed for binary classification problems. Now let's understand what is binary classification. It actually means making the decisions between two possible outcomes, that is either yes or no, true or false, or 0 or 1. The basic structure of perceptrons looks like this. It receives multiple inputs, processes them, and decides whether the neurons should activate or not. So here are inputs, weighted processing, and the decision, and then the output. Now let's understand core components of perceptron. The first is inputs. The inputs are the features of our data. For example, if we are predicting if a house will sell or not, here the input might be the size of rooms, location of a house, number of bathrooms in that house, and different features like this. Next is weights. Each input has its weight. This represents the importance or the strength of each input. The perceptron does not treat all inputs equally. If an input is highly critical to the output, its weight will be large. For example, study hours may strongly relate it to success of an exam, whereas sleep hours may have lower importance. The learning in a perceptron means adjusting these weights properly. Next we have is summation. Summation means we multiply each input by its weight and then add them together. Hence, we get weighted sum of all inputs. Bias. Bias is an extra parameter added to the weighted sum that allows the model to shift the decision boundary. It helps the perceptron to correctly classify the data even if the inputs are 0. Activation function, a mathematical rule that transforms the combined input signal into a final output, is the activation function. The common activation functions are step functions, sigmoid, rectified linear unit. Output is the final result made by the perceptron. Now let's see how perceptron works step by step. Step 1. At first it receives input. Step 2. Compute the weighted sum. Here we multiply each input by its respective weight and add them together along with the bias. Step 3. Applying the activation function. The weighted sum is then passed through a step function. If it is greater than or equal to 0, the perceptron fires. If it's less than 0, it stays silent. Step 4. Compare prediction with the actual answer. If the prediction is wrong, error is detected. Step 5. Update the weights. That is called the learning rule. If the perceptron makes a mistake during the learning, it adjusts its weight and bias. Step 6. Repeat many times. The prediction, it improves with the repetition. Lastly, we get the final model. After training, the perceptron produces the final predictions. So this is how the perceptron works. Perceptron through logic gates. Logic gates are very important because they show how perceptrons make decisions mathematically. We have AND gate. The AND gate outputs 1 only when both inputs are 1. So here's the truth table. If the input A and B are 0, then the output is 0. If the input A is 0 and the B is 1, then the output is 0. If input A is 1 and input B is 0, then the output is 0. But if A and B both are 1, then the output is 1. So, in this case, the perceptron learns like this. Activate only if both conditions are satisfied. Next we have is OR gate. The OR gate output is 1, only we have at least one input is 1. Here is the truth table. If A and B are 0, then the output is 0. If A is 0, the B is 1 and output is 1. If A is 1 and B is 0, the output is 1. If A and B both are 1, then the output is 1. XOR problem. This is one of the most famous problems. In exclusive OR, the output is 1 when the inputs are different. Here's the truth table. If the input A is 0 and B is 0, the output is 0. If input A is 0, B is 1, then the output is 1. If input A is 1, B is 0, then the output is 1. If both input A and B are 1, then the output is 0. Why perceptron fails here? A single perceptron can only create one linear decision boundary, but XOR requires non-linear separation. Hence, perceptron fails if the data is arranged in non-linear patterns, as it can only create a straight decision boundary. So due to this, it led to the evolution of AI like this. We have perceptron, then we have the multi-layer perceptron, deep neural networks, and these modern AI systems. Types of perceptrons. One is single layer perceptron and the another is multi-layer perceptron. Now let's launch single layer perceptron. So this is the simplest network consisting of just one layer of output nodes. It solves only simple linear problems. Multi-layer perceptrons. There are many input layers in it. It contains one or more hidden layers and the output layer. Multi-layer perceptrons, it can solve non-linear problems. Limitations of perceptron. Linear decision boundary. Perceptrons cannot solve non-linear problems like XOR. Limited complexity. Perceptrons cannot learn hierarchical patterns. Weak representation. Perceptrons struggles with images, speech, and language. Binary outputs. Perceptrons are mostly limited to yes or no decisions. Hence, these are some of the limitations of perceptrons. How the problem is solved. The problems of perceptrons can be solved by using hidden layers, because hidden layers allow multiple stages of learning. Next is by using the non-linear activation functions, because it allows curved and complex boundaries. And third solution is by using the deep architectures, as many layers create hierarchical understanding. So these are some of the methods to solve the problems of perceptrons. Summary. Okay, this much for perceptron. We understand that perceptron is the artificial neural model. It learns by adjusting weights of an input. It solves linear problems, and it fails on non-linear problems like XOR. It led to multi-layer neural networks. Hence, it became the foundation of deep learning. This much for today. I hope you all learned something from this video. If you enjoy, do not forget to like, share, and subscribe to my channel. Thank you for watching. I will see you all in the next episode.